The term centrifugal means away from the center. A centrifugal force is an apparent force. It exists only in a local reference frame and is an effect of inertia. Let's consider an amusement park ride, the gravitron. If we take a bird's eye view of you riding this amusement park ride, basically this is the top of your head and your eyes are pointing here towards the axis. And what happens is this amusement park ride starts to go around and around, and at some point the floor drops out beneath your feet. And so there you are, standing with nothing to stand on. And you feel as if you're pressed against the side of the ride. Now, from your point of view, that feels very real. You feel as if you are pressed against the outside of the ride. But let's examine that a little more closely. From your frame of reference, you feel a centrifugal force pushing you into the pads. And you can see, if you look at the top of the screen, we're taking your position as being right there. So you feel like there's a force downward pushing you there. And I would have to ask you, what is pushing you? What is pushing you downward? What is there in front of your face right there? And the answer is air. Now, let's pretend that we're watching you from a bird's eye perspective. So now we're looking down and we're seeing you go around in a circle on this ride. From the bird's perspective, when we see you go around in a circle, we see the pads pushing on you with a center-directed force, a towards the center force, changing your state of motion. In other words, the bird sees the pads pushing on your back, where you perceive a force pushing you in the front, in your chest, you might say. The bird sees the pads pushing you in the back, causing you to go around in a circle. And the odd thing is that this centrifugal force, to us, seems extremely real. It really feels like something is pushing you in the chest, holding you against the pads, when in reality, what's happening is the pads are pushing you in the back, causing you to move in a circle. The magnitude of the centrifugal force that we perceive is actually equal to the magnitude of the centripetal force that actually exists. Let's try this problem. A student of mass 55 kilograms rides a bus moving 15 meters per second around a curve of radius 16 meters and is pressed against the window. Find the centrifugal force the student senses. So we have a student on this bus, and the bus is perhaps going around an interstate on-ramp, and the student feels pushed against the window. Well, what's actually happening is the window is pushing in the opposite direction on the student, forcing the student to travel in a circle with the bus. The centrifugal force that the student senses is actually the centripetal force that the window is pushing on the student with. So let's look at the equation for centripetal force. Let's check off the variables that we know. We know the student's mass, we know the speed of the bus, we know the radius. So we're going to use the middle form of this equation. Of course, the speed of the bus is the speed of the student, so both of those are 15 meters per second. 55 kilograms times 15 meters per second squared divided by 16. That's the force that the window is on the student, and that is the force that the student perceives is pushing from the other side into the window. Final thoughts on centrifugal force. Centrifugal force is a force one perceives due to some kind of circular motion. It involves an object's inertia, that is, its tendency to maintain a constant state of motion, and the circular motion of either the object itself or the surroundings. When examined from a more global reference frame, centrifugal force can be shown to be either the very real centripetal force that keeps an observer in a circular path, or the absence of such a force while the surroundings rotate away from the observer.